Another application of so S is displacement, the derivative of S is velocity, the derivative of velocity is acceleration. So in our applications unit, we mainly worked this way. And now that we've learned integration, we can also work backwards and have all sorts of questions. They could start us off in the middle and you could go in both directions and so on and so forth. So here's one. We've got acceleration, t plus 1. Find the equation of the velocity. So velocity will be the integral of acceleration. Our variable is t, so dt. If we write that out, what is the integral of t plus 1 dt? Add 1 to the exponent and divide. And we have a plus c at the end. And if we are given information, for example, they tell us that v equals 8 when t equals 0, well, then we can figure out that c is equal to 8. And so now we have our velocity equation is t squared divided by 2 plus t plus 8. Now our displacement equation will be the integral of our velocity and in a question like this, you have to be a little bit careful. So we add 1 to the exponent, divide, we'll have t cubed over 6 plus t squared over 2 plus 8t. And you might be tempted to do plus c again, but since in the same question, you're going to have to use a different variable this time. And we were also told when t is equal to 0, s is equal to 0. So we can plug that in. S is 0, t is 0, so this will be 0 plus 0 plus 0 plus d. We'll have to write plus 0. That would be our equation for our displacement. So again, this one, we started with acceleration. The whole way through, we were going this way. Anytime you're going up, that's integrating. Anytime you're starting from somewhere and going down, you're going to need to use the derivative. So in question number 2, right, we're given the velocity, and they want us to find the acceleration. So I'm thinking, okay, I have to do the derivative. So the number one thing that you can mess up here is just doing the wrong thing, integrating instead of doing the derivative. In this case, if I do the derivative of that, I'll just write dv dt, it would be negative 10 meters per second squared. If I want to find s, that would be going from my velocity up. I'm going to need to do the integral and anytime they say initial, that's telling you that time is 0. So an initial displacement of 40, so I can plug in 40, I can plug in 0. So C would have to be 40, so my final displacement equation, 50t minus 5 squared plus 4d. Okay, they give us in the equation acceleration. So if we're given acceleration, the only way we can go is backwards. So we're going to have to integrate here. So our velocity in this question would be the integral of 2t minus 4 dt. Add 1 to the exponent and divide. And they tell us when time is 0, v is 3. It's pretty easy to plug 0 in for t. It's really nice when they give us an initial one rather than saying at 3.5 seconds. You're like, oh, I've got to plug everything in. So our final velocity equation will be t squared minus 4t plus 3. Displacement would, of course, be the integral of velocity. So our displacement will be t cubed over 3 minus 4t squared over 2 plus 3t. Now, in an IB exam, I think they would be a little bit lenient here if you decided to use C again, because it's in a part B, right? It's not in the same question. Although, since it's all part of the same thing, I kind of like to use still a different letter. Doesn't hurt. Here we're told that when t is 0, s is 2. So again, it's pretty easy to figure out that the d value has to be 2. And so our final equation for our displacement will be t cubed over 3 minus 2t squared plus 3t plus 2. The next one, we have to know what does it mean for something to be at rest. When something is at rest, its velocity is equal to 0. So a lot of these kinematics questions are, here's some information. With this information, you can find all 3 equations. We've got an equation for displacement, equation for velocity, equation for acceleration. And then, can you know which equation to use? So if the velocity is at rest, or I mean, if t is at rest, the velocity is 0. So I go to my velocity equation, and I plug in 0. T squared, wow. T squared minus 4t plus 3. This factors nicely. T plus t minus 3, t minus 1. So t is equal to 3, and t is equal to 1. What are our units? 3 seconds, 1 second. So it's at rest at 3 seconds, at 1 second. And so we need to find the displacement at these times. So let's do t equals 1 first. S would be 1 over 3 minus 2 plus 3 plus 2. As a mixed fraction, 3 1/3. And displacement, is that in meters? Yes. And when t equals 3, 3t cubed over 3 will be 9, minus 2 times 9 minus 18, plus 9 plus 2. So again, part D, it's asking about displacement. We would go to our displacement formula and figure that out. Now, one of the trickiest things that comes up in kinematics is the difference between displacement and distance. When I throw a golf ball up in the air and catch it at the same place where I threw it from, its displacement is 0. But it has traveled a distance. It traveled the distance up, and then it traveled the distance down. I think that's one of the reasons, like, I love playing sports and I love playing games, but I'm not a runner. I don't really like to go out my front door and go, okay, I can run around the block and get back to where I started from in 5 minutes. But wouldn't it be more efficient if I just didn't go for a run? I'd be back to where I started a lot quicker. That would make more sense to me. And so for me, I can run if I need to go from point A to point B, and I have no other way to get there, and I'm late. I can run. But if I'm going to run around the block just to get back to where I started from, I know it's probably good exercise. And it's probably good for my health. But I find that not very motivating. So, right, but put a soccer ball out or something like, oh, you have to run it, then that has motivation for me. So I can do that kind of running, and I can do that for sometimes for a very long time, which I don't know if that's healthy either. Playing a sport until the next day you can't actually walk anymore. But so we have displacement is just the integral of our velocity. But our distance, we have to find out when is the displacement positive, when is the displacement negative. Because if I would take my velocity graph of this object going up in the air, I would have a positive velocity while it's going up, it's going to stop, and then it's going to have a negative velocity showing that it's coming down. When we integrate for the distance, we have to take into consideration that that negative velocity is an area underneath your x-axis, under the curve. And so when I throw this up and have it come back down, I would have, with my integral, got a positive displacement, then a negative displacement that canceled each other out. But if we took that negative displacement, put absolute value bars around it, made it positive, then we would get our answer. Even better, to do this if you have a calculator, another thing you can do of T1 to T2, does it make sense if you just make your velocity the absolute value of it right from the beginning, then there will be no areas under the curve. Because here's our, let's say we have some graph like this, some sinusoidal, there's a part above, a part below. What would happen to this graph if I put absolute values around it? It would just flip the bottom part up. And now when you find the area under the curve, it would all be positive and it would calculate the distance. So you have two options for calculating the distance, right? If this is a non-calculator question, this is what you would do, because we have not done integrals of absolute values inside. But if you have your calculator, why not put it in absolute value? And then you can just find the area from one place to another. That would be quicker and easier. So if a question is asking for displacement, then you're just going from 0 to 3 pi over 4 . And if this was non-calculator, we would figure out, okay, the integral of 1 is just t. The integral of negative sine 2t would be positive 2 cos 2t, and you'd have to divide out the chain rule from 0 to 3 pi over 4. So remember, for definite integrals, you plug in the top number first, 3 pi over 4 plus, and if you plug in 3 pi over 4, you will get cos of 3 pi over 2. Is that on your pi plate? Yes. That's a value you've memorized. 3 pi over 2 is here at the bottom. Cos is which coordinate? The x coordinate. What's the x coordinate down here? All of that thinking just to get nothing out of it. And then we subtract, and now we plug in 0. This will be 0 plus, and then we would have cos of 0. Again, think of your unit circle. Cos is your x coordinate. At 0 would be 1. What do we get in the end? We get 3 pi over 4 minus 1. As a single fraction, that would be 3 pi minus 4 all over 4. What's the distance traveled? Well, now we have to think about this graph. Now we have to think about, where is this graph? What does it look like? I would probably, if I was thinking about this graph, rewrite it in the form that you're more used to graphing it from. It has an amplitude of 1, a center line at, an amplitude of 2, a center line at 1. So if I'm imagining this, my center line is at 1. My amplitude means I have a maximum at 3, a minimum at -1, a period of 2 pi divided by my b value, so my period would be pi. Split that into 4 equal sections. And a sine graph starts in the middle, normally going up, but this sine graph would start in the middle, going down. And so here is what I have, and I want to find the distance traveled over the first 3 pi over 4. If this was non-calculator, I would need to find out this point and this point, and have to figure out this area would be positive, and this area would be positive, and this area here would be negative. I would have to find those values and plug them in, okay? Is it easy to solve where this is equal to 0? It's not bad. So we can pretend this is a non-calculator question, and then after we'll look at what you could do for a calculator and how much easier that would be. So if this is a non-calculator question, I already know what the integral is, but I'm going to need to find these 2 points where it hits the x-axis. So I would plug in 0, and I could get sine 2t by itself by moving the 1 over and dividing by -2. So I get sine 2t is equal to 1/2. And that is a value that you should recognize. Sine is equal to 1/2 in your pi over 6 family in quadrant 1 and quadrant 2. But we don't just have a t inside. we have a 2t inside. So that means the 2t that's inside has to equal pi over 6 and 5 pi over 6, which means t itself has to be pi over 12 and 5 pi over 12. So our distance formula, again, if we didn't have a calculator, our distance formula would say we would go from 0 to pi over 12 of v dt. This part is going to be positive, plus we do the integral from pi over 12 to 5 pi over 12 of v dt. And once we find that answer, we'd have to take the absolute value. And then finally go from 5 pi over 12 to 3 pi over 4 of v dt, and that one is positive already. A little bit annoying, because that's a lot of calculations to do, right? We've already got our integral up here. Could we plug it in and solve it? Are we able to? It has a cos 2t, so when you plug it in, you are going to get values that will work. This is the visual. Right? When you do an integral, you're going to get the integral like this from 0 to pi over 12, and so on for each of these. So I'm doing a little bit of shorthand here, just saying, imagine we've done the integral because we have it, view, zoom, we have it up here already. So if I plugged in pi over 12, it would be pi over 12 here, plus, and this just is cos 2t, which would be cos of pi over 6, when you plug in your pi over 12, cos of pi over 6 from your unit circle is root 3 over 2. Minus, now we have to plug in 0. 0 we already plugged. Do you remember when we already plugged in 0 from before? So we can cheat and steal that from above. It'll be 0 plus 1. Okay. We can also cheat because we did the pi over 12 here. It's going to be there in that one, because we have to plug in pi over 12 again. Now we have to plug in 5 pi over 12. 5 pi over 12 would be 5 pi over 12, and then when you plug it in here, you will get 5 pi over 6. Cos of 5 pi over 6 is negative root 3 over 2. And the last one, we can steal values from before because we've got the 5 pi over 12 minus root 3 over 2 from this one, and 3 pi over 4 minus 0 from that one. Wow. So there's just a lot of calculations that need to happen here. So we can now put all of this stuff together. This is going to be a negative answer, so we need to have those absolute values to make it positive. And we can simplify from here, which I'm sure, do you want to do it? Do you feel like simplifying all that? Do you want to watch me do it? Not really? Probably what I would do, just some mathematical tricks that I would know. I know that this answer is negative. So I can take this whole thing and change it to brackets and put a negative in front of it, because that negative in front would multiply by the answer, which is negative, which in turn would make it positive. So if I did that, 5 pi over 12 minus root 3 over 2 minus pi over 12, distribute this negative plus root 3 over 2. Some things I notice is those nicely cancel out. Not happy with this. Thought this was supposed to be negative. Did I do something wrong? Great. That integral should be negative, according to my graph. If I plug things in, it's coming up positive. So, let's take a break and do it on the campus. We'll come back and look if we can find our mistake in a second. But this should come out negative, and it's not, so I'm a little bit not too happy. So go to our calculator. We can type in our velocity equation, which is negative 2 sine 2t plus 1. And we're looking over the first 3 pi over 4 seconds, so we can set, maybe we'll start at -1 just so we can see our x-axis. 3 pi over 4, maybe I will just go a little bit further and go pi. If I make my scale pi over 4s, that might be nice. And as far as our graph, because we drew it here, we need to see from -1 to 3. So if I go from -2 up to 4, this should give a nice little bit of a graph. Okay? Now just to check if our answer in part A was right, where we found the displacement, we can go second calculate number 7, the integral, starting at 0 and going up to 3 pi divided by 4. And we got a displacement of 1.356. What did we get as our answer for that one? Oops. Oh, we got 3 pi minus 4 over 4. So I'm just going to double check if we have the same answer. Yay! Okay, that's at least a little bit exciting because part B was going so terribly. Things weren't working out. Now, if you were using your calculator, do you know how to put absolute value bars in your calculator? Okay, second, insert under math, over to number, they have this, abs. That's not abs like stomach muscles, this is absolute value. So we push that in, insert that there. Oh my goodness. I might have, oh, I'm going to show you a new trick because I really don't want to retype this all. So I'm going to do here, math, number 2, number, abs. Here's a new trick with your calculator. If you have an equation written under vars, hit the vars button, which stands for variables, and then go over to y variables, and then function. It's a long ways to go. There's a shortcut for this too. If you do that, it lists all these functions, and if I push y1, it'll say, oh, you just want to take the absolute value of your first graph? If I hit graph, it still is my blue one, but now you can see it just did the absolute value of that blue one. Second, calculate. How do I find the, first of all, you can use your arrow keys up and down to switch which graph you're using. And now I can find from 0 as my lower limit up to 3 pi divided by 4. Woo! That's so pretty. And the answer should be 2.72. Most likely, this question would be one that would find this without with a calculator, because it's just where we're at in our calculations right now. It's just sort of like, we could do it, but it's tedious. Now, it still hasn't explained why we have a wrong answer for this middle. Oh, there it is. You see this plus sign? Sneaky. That should have been a plus sign, in which case those things wouldn't have canceled out, because this one would be a plus sign. But that just makes it bigger. Okay, we're still struggling. Yeah. Yeah, you don't want to watch this anymore either. Oh my goodness. All right, we probably made a mistake somewhere else. Doesn't matter. This part, if we calculated it out, what should it be? We can go back to our graphing calculator, and I'm going to find the area underneath the curve of the blue one. I'm on the blue one, from lower limit of pi over 12 to an upper limit of 5 pi over 12. So the nice thing is, we did correctly find the pi over 12 and 5 pi over 12. It should come out as a negative 0.684. That would be, this section should come out to negative 0.684, where we have our calculation error. Oh, wait a minute. This should also be a plus sign, which would make
Sorry for the interruption.
the same issues we had before.
Tonight's session is canceled. That's Rec and Read for tonight. It is canceled.
We will end this question. It's great. With a nice sad face. And then think about where we're at. And where we're at in our notes is the last page of our notes. So take the absolute value of that and change it to a happy face, because we are done integration, which happens to be the last unit, which means we're done our notes. It's kind of exciting.